Bismillahirrahmanirrahim. Assalamu alaikum to all of you. This is abbasi here. Today we will discuss the chemical equilibrium, right? And then we will also discuss the factors affecting the equilibrium position. Bismillahirrahmanirrahim. These are the learning objectives of today's topic, right? That today we will discuss about the reversible reaction. Then we will discuss about the examples of the reversible reactions. Next, we will discuss about irreversible reactions. What are the irreversible reactions and the examples of the irreversible reactions. Then third, which is very important, that what is chemical or dynamic equilibrium. Then what are the factors, which is very important topic on the paper point of view, exam point of view, that what are the factors affecting equilibrium position, right? Number one is concentration, number two is temperature, number three is pressure, and number four is the catalyst, right? So this is the complete picture of the today's topic which we will discuss. Now first of all, what do you mean by the reversible reaction? A reversible reaction in which reactants are not completely converted into products is called reversible reaction, right? Where there are some unreacted reactants, you can say that, remaining in the product side. So this is called the reversible reaction, and these are the three important points related to the reversible reaction. That number one, it is also called both way or direction reaction, and it can go forward and backward also. So this is the reason that it is called the forward both way direction reaction. Means it can go from reactant to product side or from product to reactant side, means forward reaction and backward reaction. It is denoted by the double arrow, right? So this is the third point related to the reversible reaction. Now these are very important examples of the reversible reaction. That phosphorus pentachloride, it can be converted into phosphorus trichloride and chlorine gas. So this, we can say, that is a forward reaction, right? This will be the forward reaction. And what will happen when this is reactant side and this is the product side. So what will happen when they both combine, then they can form the phosphorus pentachloride. So this will be the backward reaction. Right? So this is the forward or backward reaction. Similarly, when nitrogen reacts with hydrogen, and then it will produce the ammonia, right? So this is also reversible reaction, means reactant can convert it into product and product can be converted into again reactants. So this is both way direction reaction, forward and backward. Then last one, hydrogen iodide can be converted into hydrogen and oxygen gas, and then hydrogen and oxygen gas can be combined to form hydrogen iodide, right? So these are some examples related to the reversible reactions. Now the second important term is what do you mean by the irreversible reaction, right? So this is the definition of the irreversible reaction, that a reaction in which reactants are completely converted into products. There are no reactants remaining on the product side. All the reactants are completely converted into product, right? And look at here, these are the 3 points related to the irreversible reaction also, as I mentioned earlier, 3 points in the reversible reaction. Number one is that it is also called as a one-way reaction, one-way direction reaction, right? And second point is that it can only go one direction, means it can only go forward, means it can only reactant react to form the product, right? The last point is that it is denoted by the single arrow, like look at this one. This is the arrow and it is used in the irreversible reactions. Now look at the examples of the irreversible reaction, like sodium chloride is reacting with silver nitrate. Then as you know that it is positive and it is negative, positive, negative, these are ionic compounds. This first positive will react with this negative anion and it will produce sodium nitrate, look at here. Then this positive will react with this negative ion, it will produce silver nitrate. So this is the way how to write the chemical equation. Similarly, calcium hydroxide, calcium will be positive, OH will be negative, hydrogen will be positive, chloride will be negative. So this will react with this chloride to produce calcium chloride, and then this will react with this one to produce water, right? So this is the equation related to the calcium hydroxide and hydrochloric acid, right? So how to balance this equation? So we can write 2 here, okay? So hydrogen will be, now it will be balanced. Hydrogen will be 4, hydrogen will be 4, oxygen will be 2, chlorine will be 2, calcium will be 1, calcium will be 1. Now it is balanced, right? So this is the second equation related to the irreversible reaction. They are called one direction reaction. They can only go in forward direction. So that is the reason that it is called the one direction reaction, and that one direction is the forward direction. Now the very important topic is that what do you mean by the chemical equilibrium or dynamic equilibrium? A chemical equilibrium in which rate of forward reaction is equal to the rate of the backward reaction. This is the definition of the chemical equilibrium, right? So it is also called as the dynamic equilibrium, right? Now we are moving towards the we can say that factors affecting the rate of reaction, factors affecting the chemical equilibrium. So these are the factors, as you know, I have already told you that in the factors, number one is concentration, number two is temperature, right? Number three is pressure, and number four is catalyst. Sorry. Right? So these are the 4 factors affecting the equilibrium position. Now we will discuss one by one these factors in detail along with examples. Now the number one is the concentration. Look at the main idea. If we increase the concentration of, for example, reactant side, right, equilibrium will move towards the product side, right? So this is very important point, that if we increase the concentration of reactant, then what will happen? It will move to that direction to reduce the concentration. right? So it means it will move to the opposite direction. Means if we increase the concentration of reactant, it will move towards product side. If we increase the concentration of product, it will move towards the reactant side. Say suppose this is the example where sulfur dioxide is reacting with oxygen and it will produce the sulfur dioxide, right? Okay, then if we increase the concentration of the oxygen here, right, it will produce sulfur dioxide, sorry. Okay, now if we increase the concentration of oxygen here at this reactant side, then what will happen, as I have told you earlier, that equilibrium will shift to the opposite direction. Means this will be the opposite direction, means it will move forward, right, in forward direction, and more amount of product, that is SO3, is produced, right? Sulfur dioxide is produced. So this is the one example of the related to the concentration. And if we decrease the concentration, right, this is about the increase the concentration. If we decrease the concentration, what will happen? For example, if we decrease the concentration of the oxygen, it will move again to the backward direction, means to the reactant side, right? Now the temperature, which is very very important. Here we have to identify the reaction, right, whether it is endothermic or exothermic, then we can answer it properly. For example, say suppose the reaction is endothermic, right, and as you know that in endothermic reaction, heat energy is absorbed, right, from the surroundings. This is the example where nitrogen is reacting with oxygen and then nitrogen monoxide is produced, right? This is the example of the endothermic reaction. Now if we increase the concentration, or sorry, if we increase the temperature here, then what will be the effect on the equilibrium position? As I have told you earlier that you people have to write two, we can say that, points, because the question will be of the 2 marks, so it will require 2 main ideas. Similarly, in this concentration question, you people have to write 2, you can say that, ideas, and that is the reason that there are 2 marks in the past paper question, which I will discuss the question related to the chemical equilibrium. So this is the temperature. Now we are moving towards the this temperature, but where there we will decrease the temperature. Now look at here, same example is here, but B part is that here if we decrease the temperature, then what will be the effect on the equilibrium position, right? Look at here that if we decrease the temperature, right, in this endothermic reaction, what will happen? It will shift, equilibrium will move, or equilibrium will shift towards the backward direction, right? And here the more amount of reactants are formed, are produced, or is produced, right? So this is the we can say that point related to the second idea, where we decrease the temperature in endothermic reaction. This was related to the temperature, right? And this was endothermic. As I told you that we people have to identify the reaction, whether it is endo or exo. So this was the example related to endothermic. Now we are moving towards the temperature, but we have to identify, as you know, whether the reaction is endo or exo. So now the second is that the reaction is exothermic reaction. right, where you know that heat energy is released from the surrounding. An example is that nitrogen monoxide is reacting with oxygen and it will produce nitrogen dioxide, right? So this is the example of the exothermic reaction. And as you know that there will be two, we can say that possibilities. One, if we increase the temperature, then what will be the effect on the equilibrium position? As I have told you earlier that you people have to write two ideas and there will be 2 marks. Equilibrium will shift. Similarly, you will answer it in the same way, that equilibrium will shift towards backward. Why it is moving backward? As you know that exothermic reactions release heat energy, right? And there is no need, the reactant will be reacting to produce the product, right? So in this case, if you give more heat, then as you know that this is reversible reaction, what will happen? This product side will move towards the backward side, means reactant side. So that is the reaction, that is the reason that you have to write the backward direction or the left side, or you can say that reactant side. You can write any one of them, right? Reactant side. So now look at here, more amount of reactants that will be produced, right? Like in the we can say that reactant side, nitrogen monoxide and oxygen are there. So this is the temperature and the exothermic reaction, and here we are increasing the temperature. Then look at here, another second case, B part, is that if we decrease the concentration, if we decrease the temperature, then what will be the effect on the equilibrium position? Similarly, you have to answer and 2 sentences. Number 1, equilibrium will shift towards the forward direction, and forward direction will be this one. And what will happen? More amount of products, means NO2, nitrogen dioxide, is produced. So this is the temperature. So we people have to identify whether the reaction is endothermic or exothermic. And then if we identified the endo and exo, then we have to write the 2 main points: if the temperature is increased or if the temperature is decreased. This we people have discussed in detail along with examples one by one. Now the third, which is very important, that what will be the effect when we increase the pressure or decrease the pressure in any chemical reaction, in any reversible reaction. Now look at here, we have to identify 3 conditions. In the temperature, we have to identify 2 conditions, whether the reaction is endo or exothermic. But here in pressure, we have to identify the the 3 conditions. Number 1, you must know, you must highlight, you must identify that products, number 1 is that products have greater volume than the reactants. Volume means, you can say that you can identify the volume means with the help of the number of moles, right? And the second point is that reactants have greater volume than the products, right? So this is the second point. And third point is that both products and reactants have the same volume. On the both side of the reactants and the products, volume or number of moles, that is same. So we people have to initially find these 3 possibilities, any one of these, right? Then how to answer? Look at the next slide. Say suppose for example the products have greater volume than the reactants. This is the first, we can say that possibility. Like look at here, reactants, they have the mole ratio, that is number of moles, or volume, that is 2, but here at the product side this is the 3, right? So products have a more or greater volume or more number of moles as compared to reactants. Then if we increase the pressure there, then what will happen? The main idea, as I am telling you all, that whenever there is increase the temperature, increase the pressure, equilibrium will move towards that side where there are less number of moles. This is very important, that when there is increase in the pressure, right, then equilibrium will move towards that side where the number of moles are less, right? So take this example, the number of moles are less to the reactant side. So look at the answer. Equilibrium will move towards the backward direction, or the reactant side, or the left side, right? And then more amount of reactants like O3 will be produced, is formed, right? So this is the one, you can say, that area, as I told you, that when the products have greater volume than reactants, then what will be the condition. Now we are moving towards the same. If we decrease the pressure, what will be the effect on the equilibrium? As I told you, that if we increase, equilibrium will move towards that side where there are less number of moles, but if we decrease, then what will happen? It will move towards that side where there are more number of moles. So equilibrium will shift towards the forward direction, because there are more number of moles here, right? And look at here, equilibrium is moving towards in this direction, means reactant side from product side, so there will be less number of moles, right? So these are the two main points. Okay, then more amount of product, that is O2, will be produced, right? So this is the one case related to the pressure.